Okay, and I seem to be sharing my screen as well, so we should be all good to go for the second lecture of social computing for this fall, and we can end the cosmic relaxation that I chose from YouTube this beautiful morning for your viewing pleasure while we waited for the official time. All right, so second lecture of social computing, and as you know, probably know there's only 6 lectures in this class, so 2 hours from now we're already 1/3 done with the lecturing part. And before we dive into the formal topics of today, I wanted to start with a little bit of historical anecdote about the phone again. So we discussed the video phone last time, but there's this very nice and interesting article about the pleasure telephone, which is basically, it's written in 1895 and it's over 100 years old. Thus, with your short math, you can count that. But basically, a long time ago, this forecast that when we are able to socialize remotely will completely cause like a revolution in everything. Earth will be in truth a paradise, and distance will lose its enchantment by being abolished altogether. So there would not be this kind of distance wouldn't be a thing anymore. Already at that point, when we have something as simple as a video call. I linked the article there, so it'll be in the slides. It's a good read and nicely allows you to dive into the minds of futurists 100 years ago. I found these images in the article also very nice. So this is how you get to enjoy the cricket news at the club. Well, that's not so far-fetched from the truth, actually. I mean, that's what the television news is these days. And then this is particularly interesting in these remote work times. So the children's lecture. So 100 years ago, they were looking into the future and forecasting that, oh, we will be having lectures remotely. And this hits pretty nicely home today. This is exactly what we're doing, with the exception that you guys are not children, but this image is fairly accurate what we're actually doing here right now today. Yet the world hasn't turned into paradise, and distance hasn't lost its meaning, has it really? Distance still is a big thing in our lives, and yes, the world has gotten smaller, we can get around, but distance hasn't gone anywhere. We have the perfect video phones available. I can take my smartphone and call any one of my contacts with basically cost-free IP technology using video, but still the distance is a big thing. And the sort of key lesson in all of this ranting is that it's bloody difficult to foresee or forecast what the actual real world effects of technology will be. It's easier to see what kind of technologies are going to be invented. What's it going to be in 50 years? What's going to happen when we have more bandwidth, bigger connectivity? We have higher resolution technologies. We know that. We know where it's going. We know what the next steps of AI is. We write science fiction about that kind of stuff, and then at some point in the future it comes true. But we don't know how it affects our lives. So at some point people were thinking that when we just crack this big thing of having video and audio in the same packet, we no longer have the need to travel, basically. And look what happened. This is what happened. We have the communication. We have all the communication tools in the world we have, but yet we've been traveling more and more, with the exception, of course, of this pandemic situation. But this is just a blink of an eye in our recent history. So just 1 year ago, this was the situation, and it's at some point it's going to be this again. So even though we got the technology, we couldn't crack the need for human communication face to face. There is still something magical in face-to-face encounters, and this makes also it very difficult to build social computing systems that are somehow trying to emulate the human connections that we have with other people. Yes, we can make things easier, but it's just not the same. Then there's this thing that we just don't really understand yet, how humans communicate with each other. And I added there a woo-woo alert there because this is not something that is based in scientific literature. And obviously that's something that I cannot be speaking here as a formal truth then. But for instance, there is this hypothesis that we have these little balls called exosomes in us. And when we are in the same room, face to face, an actual social conversation around the same table, what happens is that we breathe in and out the exosomes of other human beings, and these exosomes end up actually manipulating our cognition. So we develop as a function of other people's near us. Now, if this hypothesis, again, remember, this is not confirmed yet, but there is a theory. Actually, researchers in Oulu are also looking into this at the biomedical faculty. But there is a theory that our evolution is partly driven by something called exosomes. Well, imagine if we now start communicating only remotely. We are basically taking a part of how the animal called human evolves as a function of swapping these exosomes with people near you. If we remove that piece from the equation, we might be royally screwed. That's just out there as an interesting thought play, which may or may not be true, but it has to do with how our social encounters may even develop the entire species, and is therefore sufficiently relevant to this class as a discussional topic, at least. End of history anecdotes. Lecture 2. Today we're going to talk about human computing and crowdsourcing as the biggest ways of basically getting work done online and somehow leveraging the social animal that we are. If we have time, we will go to Wisdom of the Crowd, and I have no reason to go there if we don't have time. I want to take my time to talk about that. So if it looks like we're happy enough today with just human computing and crowdsourcing, I'm going to just cut it there and then leave the Wisdom of the Crowd for the next lecture. So let's see. Housekeeping issues, not much. Make sure that you're in Moodle. Probably you are in Moodle because I left this Zoom link there pretty late this time. I forgot to create the meeting, but at least you who are here happily have found here, so it's fine. The reflection homework, I think the deadline was already September 10, so that's in 2 days from now. Please do finish that. And we have the forums in Moodle. They're unbelievably clumsy. The user interface is pretty bad there, but especially when the exercises start, feel free to use the forums for whatever. So if you need to find, for instance, group members, if you want to switch groups, if you have some questions and stuff, use the forums. It's often so that when you have a question, more than one people have the same question, and it's just much more handier if you ask those questions there instead of emailing me, because I can just might as well reply to everyone at the same time. And the exercises start the day after tomorrow, so be there. Let's move on. So human computing, the bigger picture of things. Yep. So like I was trying to say earlier, human computing and crowdsourcing are actionable topics, meaning that it's not so theory heavy, and they are sort of real world applied social computing aspects that get work done. And most of the things that we try to develop are for getting work done. So we're trying to basically make humans do or create something that computers cannot. Luckily for us, there are plenty of those kind of things still left to do what computers cannot do. And the labs are somewhere supposed to be in the middle of here. So the labs on this class focus on human computation, crowdsourcing, and the theory which we borrow from social computing. All of this is within a larger theoretical framework of collective intelligence, but let's not go there. So human computing and crowdsourcing are deceptively similar. So we're going to try to make it a bit simpler with a simple heuristic. Human computation is humans doing little tasks. So not long ago, I could have shown a picture of, let's say, an owl here. An owl. Can you see the owl? I hope you can. And ask you, what is this animal? And you would have said an owl. Now, 10 years ago, that was a task that computers couldn't solve. Now, thanks to advances in machine learning, computers know that it's an owl, but humans had to teach the computers to do that. In a similar way, right now, there are things happening in the world that computers cannot explain. Only humans can do that. Or even labeling more complicated images. If there is an owl riding a bicycle toward the moon when it's dark at night, you're not going to find a computer algorithm that can make a good assessment of the situation, what's happening there. So those kind of tasks we need humans for. And that's basically just human computing. We're doing tasks that computer cannot do. And then what makes it crowdsourcing is we're basically doing the same in a parallel fashion, but we're aggregating the end result in the end. So there's some kind of a coherent end game, what for we are collecting those small tasks. So we're basically just solving problems that are beyond the scope of your favorite technology. You can choose any technology, and we can find probably a number of tasks there that humans can do that the computers still cannot do. Depending on which AI guru you ask, there will be a point somewhere in the future when computers are better than us in almost everything and anything. But even in that case, our social connections and the creative aspects of humans are basically our strengths. So even if computer could do anything that Simo can do, which is not much, but still, if computers can do anything that Simo can do, I still have my social network, and computers cannot fulfill the needs of the people who depend on me as the human entity that I am. So human computation and crowdsourcing are just basically this kind of actionable branches, which are really trying to drill into the aspects of work that only humans can do. And of course, it's murky waters. So we're also doing something like collaborative artificial intelligence, where AI and humans are doing work together. But that's basically just the same thing. We take both of the worlds and try to get the best of those worlds. Yeah. All right. So the same thing in other words, what hardware, computer sensors, and algorithms cannot tell you, people can. A good example of this is basically, of course, all sorts of subjective data. How does something smell like? How do you feel like something is? But to dive into the more actionable parts of things again, human computation was sort of defined as late as 2000. I think this thesis is from 2005. So of course, this concept of work, concept of labor that humans can do better than computers is as old as computers themselves. But this term human computation was coined in 2005, and most notably, the CAPTCHA was a good example in a thesis by this guy, Louis von Ahn. So CAPTCHA is this sort of archetype example of human computing. We have online mechanisms that try to recognize if you are a human or a bot. Now, bots can do a lot of stuff online. They can just scrape data, they can register into different websites. There are a lot of evil things that bots are trying to do online. So there is this wall of defense against bots, called CAPTCHA. And CAPTCHA was basically just a simple tool like this to choose a word that relates to all the images. For instance, now algorithms can easily crack this, but this is a historical picture from the original thesis. And this was just a way to verify if you are a human or a bot. Now then there's reCAPTCHA, which is something which was built on this CAPTCHA concept, and it's using old books and cutting all the words in the old books into images. You have probably stumbled upon this online when you register to sites or when you try to do something. It shows you a ridiculous looking piece of text, which might be even handwriting in some cases. What's actually happening on the back end is they are digitizing old books. So these are real pictures from old books, and they just want to have the digital versions of those books. So they parallelize the work. And as a byproduct of this kind of online privacy or online security mechanism, they get the digital transcripts of the books, which is pretty genius, actually, if you think of it. So everyone benefits from this, except, of course, the poor user. A couple of years ago, I think this has been evolving thanks to Google's machine learning algorithms, so that you don't really see these so often anymore. Now they just need a click of a mouse. And how they do that, that's pure wizardry, basically. So they track how the mouse behaves, and through sophisticated machine learning algorithms, they can tell if you are a human or a bot, because bot cannot move the mouse exactly like humans do. And that's yet another thing that humans can do, but computational algorithms cannot do. They cannot move or behave in a human-like fashion carefully enough. CAPTCHA is a program that can generate and grade tests that it itself cannot pass, much like some professors. This, I wanted to highlight that because it's a very nice choice of words in an actual PhD thesis. An early example of human computation, just for fun. You have seen this in a modern format as done by Google again. So you show pictures and you ask people to describe what is this picture. Google has done something similar. They had this picture game online for some years, and then they have this drawing game as well. The only purpose of building these kind of games is really getting training data for machine learning algorithms. Because back in the day, for example, here, computers couldn't know what is in this picture. And these kind of tasks are just simple human computation tasks that with the purpose of teaching computers, because computers could not solve these tasks at the time. Now, one step up, so crowdsourcing, how do we go from this kind of simple one-off tasks into bigger entities that are crowdsourced? I like this quote as the sort of definition of crowdsourcing, even though the formal definition goes back to 2006 by Jeff Howe. But this crowdsourcing is the ultimate disruptor of distribution, because in a most Zen-like fashion, the content is controlled by everyone and no one at the same time. So we have some sort of content repository which is controlled not necessarily by a single entity, because everyone is taking part in creating it. But at the same time, everyone is controlling it, because everyone is actually contributing to the creation of that. Wikipedia is a great example of a crowdsourced information repository. And there is a crowdsourced list in a crowdsourcing project about crowdsourcing projects available in Wikipedia if you want to see other notable examples of big crowdsourcing projects, or notable enough to make it to the Wikipedia list. So it's large entities built by aggregating smaller chunks into one big thing. We have hundreds, thousands, tens of thousands, possibly hundreds of thousands of human computation tasks that are then somehow coordinated into a bigger entity. Now, yes, crowdsourcing primarily deals with work online, but it's completely unjustified to say that there's anything new about crowdsourcing. If you think of something that humans have always been doing, we orchestrate a large amount of people for one effort, and that's really it. So it took 100,000 people to go to the moon. Now, what is that conceptually, other than simply orchestrating a big bunch of people in different roles toward one goal of going to the moon, building all the stuff that's needed, and just supporting the project in general? Now, what the internet has done, it's opening up a really, really fascinating and really nice opportunity to coordinate people. So the web can bring together billions of people. Even now we have 32 people in this Zoom meeting in addition to me. So I could basically somehow orchestrate you to do something together as a group. And all it took was placing one link in the Moodle. Now, if you think of the scale of the internet, we can reach billions of people and try to build systems that leverage those people's voluntary contributions, their cognitive surplus, so to say, to build something. What can that something, for instance, be? Well, Wikipedia was one nice example. This is a screenshot that I took this morning from my own cell phone. So there's this language learning game called Duolingo. This is actually entirely crowdsourced content. So the language lessons here are created. There is a rubric or some kind of an initial frame created, but the players themselves keep error correcting this system. So this is entirely crowdsourced language learning in a way. And they also now have a Finnish language course on Duolingo. And this is also a very nice example of human computation or crowdsourcing as a business, because they are making pretty decent amount of money. What most people don't know, it's that it's the same bloody guy again. So it's the guy who actually wrote the thesis on human computation, who is the co-founder and CEO of Duolingo. So obviously that's what you want to do when you come up with a nice concept and you learn to leverage it. You build a business on top of it. And why I'm talking about Duolingo here is that I think this is actually a good business, because, and I don't just talk about the money part, but there are millions and millions of people learning new languages, learning to communicate. And again, communication is the big thing between humans. So this is a sort of a feel-good business based entirely on a crowdsourced business model, which is good for him and good for us. I paid for it, so yeah, at least he's getting my money. All right. Then I want to show a local example that we've been doing here in Oulu. So we do something called situated crowdsourcing. We had this big, ugly, and bulky, and really badly functioning, let's be completely honest here, badly functioning displays around Oulu. But these were a research infrastructure, not a commercial product. And as a research infrastructure, this was a beautiful, beautiful project. And we deployed a lot of something called situated crowdsourcing applications on these. One of these applications was Game of Words, where we were applying the principles of human computation and crowdsourcing to build a dictionary of a location. So there was simply keywords floating down in a cloud, and the cloud, you had to drag the cloud to right or to left to dictate whether the word is relevant to the location or not. Now, if we do this over and over in this kind of a setting of multiple displays in different cities, we will eventually get dictionaries of these locations. And the dictionaries of these locations can be used for a variety of purposes. Why am I seeing that weird name catalog in the picture? Are you seeing those names? Or is this my Zoom feature? Let me check something. Oh, never mind. Yeah. I have a second computer running here, which I'm double checking that the right stuff gets displayed. So apologies for that. Anyway, back to this. So what we're doing is we're building dictionaries of these locations through human computation and gamification. And those dictionaries of the location are actually a big deal when it comes to computational building of software. So again, if you look at the display in the swimming hole here, humans know what kind of a location this is, what are people doing there. But if you plant a computer there, the computer has no clue about the context. The computer doesn't know that people go there to swim. The computer doesn't know that it's a sports hall. The computer can maybe get some clues about what the surrounding is through things like, let's say, Google Maps or some map API. But essentially, we want humans to be able to teach the computers that what is this location all about. And we can do that through simple tokens called word in the English language. And what we just did is crowdsourced a lot of words that are relevant to these different locations. And that helps, for instance, choose content for that location. So what do we want to display on those screens? Another example, which we published last year, or this year basically, is crowdsourcing creativity. So creativity is something that humans can do really well. If you ask a computer to draw art, or if you ask a computer some archetypal creativity tasks like come up with secondary uses or alternative uses for a brick or a paperclip, computer will struggle to do that. They will find some information online, but as long as you ask them a question which is not already answered online somewhere, computers will come up with blanks. They cannot answer that. And what's more interesting is that turns out that you can outsource some of this thinking process to the crowds. So for example, if I want to write a creative story about coffee cups, or that's my favorite cup, as you probably know by now. If I want to write a creative story about that, I can build systems to crowdsource parts of the creative process. I can ask for all of your help in creative work, basically. Now, a different type of crowdsourcing, or a distinct kind, not necessarily different, is paid crowdsourcing versus unpaid crowdsourcing. So, for example, this example here, of course, we didn't pay anything to people. People were playing this game out of their own volition, basically, voluntarily. But there is this distinct branch of paid crowdsourcing, which is particularly interesting and relevant to the modern world. And I will explain you why in just 2 minutes. Typically, these kind of paid crowdsourcing platforms are offering rather monotonous work, rinse and repeat kind of work. You show a picture of an animal, you label this animal, you show a tweet, you categorize this tweet if it's offensive, if it's a happy tweet, if it's a sad tweet, some kind of sentiment analysis tasks. Tasks that you might have thousands or tens of thousands of instances of the same task, and humans, just like machines, complete them, done. Hundreds of tasks in a row of the same kind, for instance. This is very, very commonly used by researchers, and especially artificial intelligence researchers, but also AI companies. There are a lot of public scandals of AI companies who don't actually even have any algorithms, but they're just using these paid crowdsourcing platforms and pretending that they have algorithms. So the biggest such paid crowdsourcing platform where you can go and simply ask for people to complete these small tasks for you is owned by Amazon. And obviously Amazon is big in offering cloud services for other big companies, and they are making a significant amount of money by offering this kind of labeling work for other companies. Mechanical Turk, you can get results by simply giving them your credit card and telling them the task. We have used Mechanical Turk, for instance, in the past, even on some of our courses, because we want to demonstrate like what kind of results do people get, or what kind of feedback do people get from Mechanical Turk on their course works. And this was purely for the sake of scientific experiment, obviously not to outsource our own work for the crowds, because, well, we're basically not allowed to do that. Nonetheless, Mechanical Turk is an interesting beast. You can find 500,000 people there. 500,000 people there. Now, the problem with this is that it's not paid really well. They have big scandals in the past when they have been looking into average pay, for example, in Mechanical Turk. It's been somewhere between $1 and $2 an hour. Now, think of this. This is a result of, again, the heaven of internet where we can reach billions of people. But this enables companies in rich countries, companies with deep pockets, to pay pennies for labor. So you can basically hire people in some remote corner of the earth to do data labeling for your AI algorithms and pay $1 an hour. And this is still happening today. It's rampant and it goes on every day. Mechanical Turk workers are really powering a lot of these AI companies, basically for training their algorithms. Imagine if you have a company that needs a lot of data. You're not going to get that data easily from anywhere unless you have a product where the data collection is baked into the product, something that we will talk about a bit later. But your only option is actually to turn to Mechanical Turks of the world. And what happens here is that it's like a Wild West. Nobody cares about the workers' rights, and nobody cares about the workers' sort of rights to do decent work for decent pay. So if I, for example, request work and the workers do a good job for me, I can simply click reject and not pay them. And I can actually do this in Mechanical Turk even now. What will happen if I reject everyone? Over time, my account will get banned. But what I can do is I can just create a new AWS account on Amazon, use a new credit card and become a requester and start it all over again. So it's pretty interesting that the biggest crowdsourcing marketplace on the planet, which is used heavily by AI companies, is this. It's flying this much under the radar, and there's not much public discussion going on about the ethics of using this workforce. Now, what happens when you don't have a labor union? Grassroots organizations. So again, people using these crowdsourcing platforms are establishing crowdsourcing platforms for crowdsourcing feedback about requesters of crowdsourcing work. Now, how complicated is that? It sounds complicated, but not really. It's simply there are websites that are trying to assess the requesters of work. Because the person working for me in Mechanical Turk doesn't necessarily know who I am, or actually they don't know who I am. All they know is my username, for instance, which happens to be Simo. So this is a screenshot from turkerview.com, which shows that me as a requester, I have been paying a decent wage for people. I approve quickly. I don't give a lot of rejections, and I don't block people. This is untrue. I do block people, but the people who have been blocked haven't reported it here. Of course, all people who work on those platforms, they don't report stuff here. But anyway, it's like a grassroots organization for judging the requesters of work on Amazon's Mechanical Turk. So the kind of point here is simply that when there is this kind of ethical ethically problematic marketplace, people do organize in a social way to discuss requesters and join the effort of trying to build some sense into the use of these platforms. And it's not only AI companies that use these platforms. Obviously, a big group of people are academics like me. So all of my tasks on Mechanical Turk have been about research. If I need 5,000 people to do some data analysis for me or respond to some large-scale, simple survey, I go to Mechanical Turk and I just buy those people to do that for me. So academics are a big group who use these platforms, but then there's also the darker side of the coin. So scammers use these platforms pretty happily. This, I have forgotten which is the website where I took this screenshot from, maybe Minute Workers or Microwork, something, I don't remember, it doesn't even matter. Anyway, if you look at these job names, these are individual distinct tasks deployed on the platform. Twitch, subscribe, must have Amazon Prime. Facebook, screenshot plus pump. Vote in contest. So if you are running those silly whose kid is the cutest contests online, I can go to a crowdsourcing platform and buy my way to victory. And there's a lot of really annoying stuff going on these platforms. Amazon doesn't allow this, so there is a way to flag also tasks there. So all this kind of really crappy tasks are shooed away elsewhere. But nonetheless, there are even platforms where you can almost exclusively find this kind of tasks where people are just asking other people to go and like their Facebook page, go and vote for me in this contest. So there is this, I can't say criminal because none of this is illegal per se, but it's against the terms and content, terms of most of these sites for sure. So these sites are very interesting sort of gatherings of people to do unethical work. Let's just use the word ethics there since we get started with that. Okay, that about crowdsourcing platforms on its own. One of the most important things that you will also probably have to consider in your exercise works is the concept of labor quality. Not all contributions are born equal. And the contribution quality matters. What kind of work you do as a member of the crowd that the work is being crowdsourced to, it matters a lot in terms of the quality of the end result. Work is never born equal. In the context of crowdsourcing, we want to think of work in units. If we just think about the word work, it doesn't sound like you will have a unit of work. But in crowdsourcing, we have to do everything so that we can look it through the lens of mathematics and algorithms. So there's always a unit of work. There's a unit of labor. There is a number of tasks to be done. Here is one unit of work. Go and leave a review on Amazon. This book was written by Satan himself. This book sucks so much. It's the worst, most pretentious piece of crap I've ever read. I had to read it for school and I couldn't even finish this poorly written, atrocious piece of crap. If this book had a face, I'd punch it in the balls. 0 stars. The irony here is that this is actually a bad unit of work. This is, if your task was to leave a review, this is a really bad review. This is a bad quality review because it doesn't really actually specify how the book is bad. It just goes to say that it is bad. So while this is a funny description in itself, there is a far deeper sort of nuance to understanding the unit of labor that has gone into writing this review. This is a bad review. It's not just a bad review in terms of giving 0 stars or 1 star, but it doesn't specify why the book was bad. So why do we then produce bad work? What's the point of producing bad work if obviously the default mode for all of humanity to thrive would be to produce good work? Same thing with crowdsourcing. You will want to produce good work, especially on a paid platform, because you are not going to get paid for the bad quality work. A number of things that we suck compared to computers. So we make silly mistakes in a way that just human errors. So we forget things, we accidentally do things, we drop things from our hands, we're clumsy in that sense. We're really bad at actually doing arithmetics. So we don't, this kind of computer calculation is super simple for your smartwatch or smartphone to do, but we can't really do this in our hands. We're not good at this kind of work. We're really bad at obeying. We screw around with things. If I give you now, if I open a whiteboard here, this kind of Zoom feature where you can just go and draw things, you're going to start drawing funny things there. You're going to start drawing things there which are not funny. You're going to start doing things there which have nothing to do with this class, because we are playful animals. We like to appropriate things to our own purposes and to our own whims. This is actually a real term that's used in human-computer interaction and social computing, often appropriation of technology. So whatever piece of technology I give to you, you will find your own ways of using it. And this is why most successful social computing systems are typically very open-ended. So I leave you with a playing ground, and then you as a community find your ways to use it for your purposes, instead of me trying to dictate very carefully, like, what is this thing now to be used for? So we play it with things. We want money. We want it too fast sometimes. So we sacrifice work quality for the quick buck. And this is just not true in crowdsourcing platforms, but also in many things in life. So people want everything right away and don't see the sort of value of putting in the long-term work. We accept tasks we cannot handle. Computers are very good at setting boundaries that, okay, that's simply something that I cannot do. I don't have the capacity to do that. Humans, we are happy to accept tasks that we sometimes even know that we're not going to be able to do. We don't always care. Nobody cares all the time. Computers don't have this concept of, do I care about this task or not? I do the task. That's it. We get sick. We lose focus. Many other things that contribute to us producing crappy work. Why do we do good work? We're really good compared to robots and computers. We have intuition. Like I was explaining earlier, if we see a complicated situation, we can somehow connect the dots and build a bigger picture of that. We can construe this kind of very difficult, insanely difficult to represent computationally concepts like dodgy. It's pretty difficult to try to come up with a computational representation of dodgy. Yet everyone will understand that, oh, that's dodgy. Humans will understand what that means. And humans will pretty easily also pinpoint what exactly is dodgy about a thing, regardless of what that thing is. So the intuition then helps, especially in this kind of open-ended tasks where the task is to do something that is difficult for computers. We can basically guess our way to good work in many situations. Oh, well, quality is a topic of research as well, but let's not go there. Filtering. So filtering is a concept which deals into dividing the good and the bad type of labor. So we need to first consider the ingredients of labor. We want to, again, be talking about units. We have the tools and we have the workers. Two different things. Two sort of key concepts in terms of building crowdsourcing systems. The actual tools to do the work, and then the workers. What are some ways that we can do to try to increase the quality of the units of labor produced? Considering a labeling task, what animal do you see in the picture? We hire a bunch of workers, and every single worker proceeds to do 10 images. And you can see now we're producing, for instance, if we hire 100 people and everyone does 10 images, we're producing, or we're requesting 100 units of labor. And these units of labors are individual entities that we're interested in examining the quality of these. Now, the end game of this kind of system is to find out what is the animal in the picture. This animal, and this animal. All right, we take one image. Worker 1 says it's a cat. Worker 2 says it's a dog. Worker 3 says it's a dog. 4 says dino, dog, 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 and so forth. Now we have just achieved a marvelous feat, basically. The task was to find out what is this animal. And obviously for a single human individual, it's clear that it's a dog. But we need to find a way to generalize this problem so that computers and algorithms can solve it, which means that we need a majority vote algorithm. It's just one example of the algorithm that can be used for accomplishing this feat, basically. So we throw 10 people to the problem, and we find out what the majority of those 10 people are saying, and we decide that this is the winning answer. Now, given this specific example, it feels really like a dumb thing to do because it's obviously a dog, but this is a generalizable solution. So we can use the same thing for a lot of different things. Now we can start to, for instance, ask difficult questions that here is a surveillance camera picture. Do you think that this picture is dodgy? Is there something dodgy going on in this picture? And we ask 200 people. And we can start to try to find the sort of threshold that when there is something of noteworthy in that picture, because humans have this built-in intuition about the world. And again, a lot of AI depends on this kind of grunt training work. So it's really this simple, but the key is in the volume. So Amazon can handle millions and millions of data points per day for big companies for these kind of labeling tasks, which help building their algorithms. Okay, then how do we filter workers? What are the ways that we do in our ordinary lives to filter bad workers away from our lives? A couple of things. Pre-filter, conditional participation. So we require some kind of pre-qualifications to be able to participate in something. Think of government jobs, or in Finland, actually even most private sector jobs as well. They have a pre-filter. You must have a thesis from a university. You must be an MSc in a university. You must have a BSc from a university before you are even eligible to apply. Now, in the modern world, this is slowly going away, thank God. But these are just one of the ways that we are intuitively filtering people based on external qualification. In crowdsourcing platforms, you can do the same. So you can, for instance, set that you must speak English in order to be able to participate into my tasks. You must have completed 10,000 tasks earlier with a success rate of 95%. So for instance, in Amazon's Mechanical Turk, this is a very common pre-qualification criteria to have. You demand your workers to have completed 10,000 tasks, and 95% of those must have been approved by the requester. And it gives you some kind of a ballpark understanding that these workers are legit and they're not, for instance, bots, because obviously there are also bot workers there. Attention checks, dummy trick questions. What planet are we on? Can you write in the chat, what planet are we on? Or answer the question. More answers, please. Great. You would probably be qualified for payment in Mechanical Turk then. So we really often use these kind of questions to check, again, if the person is paying attention. If you are doing crowdsourcing work, you might be just in it for the money and you just click quickly through everything. You write blah, blah, blah to everything where you have an open-ended text box. So we have questions like, what planet are we on? Or how many moons does our home planet have? Or something simple that all humans know the answers to. But if you're not paying attention, you will answer it wrong. And you would be surprised how many people get this wrong because they are just using some kind of scripts or bots to pre-fill all the work so that they get the money. Majority vote, if you consistently do really bad work in easy tasks, we can also blacklist your IDs. We can sort of try to filter you out from the pool of allowed workers. And there's a lot of other things we can do to filter work. All right. I was surprised by this slide. I didn't remember that I left this here. That's, I guess, why it's called quick side note. So the point here is more that in these lectures, I cannot possibly touch all the ways that researchers and practitioners have devised into, for instance, filtering out workers or increasing the quality of work. There are literally hundreds and hundreds of papers every year published on how do we improve the work quality in crowdsourcing, how do we make it in an ethical way so that everyone gets paid well, and we're trying to support the worker to choose, for instance, the type of work that they're good at. There is absolutely no way to cover all of that basis. What you can do is that in your exercise in the group works, you can look into the literature, and you should be looking into the literature to factor some of these designs into your concepts. So if you, for example, design a crowdsourcing system, what are the ways that you can implement to filter out bad work? And these are all readily available in the literature. It just demands that you actually go and read the literature. And because there's such a plentiful amount of these things, it's bloody difficult to design well. There is no one right solution to design a crowdsourcing system. And even if you design one, it might fail horrendously. So it pays off to sort of look at the best practices and analyze already existing successful social computing systems, crowdsourcing systems, before you start your design work. Okay, back to our train on this. So contributions and AI. So Google. I'm talking a lot about Google. There's a reason for that. I'm talking a lot about Amazon as well, but Google is really the company that has been leveraging crowdsourcing in a beautiful way in their own products. Yes, some will say that in an evil way, or they're profiteering from their users, whatever. I don't really care about that. That's not my problem, and I'm not here to take a stance on whether Google is a good company or not. But what they are doing is they're using the exact principles of crowdsourcing to develop their products in a pretty bloody efficient way. So a long time ago, Google, for instance, did a public service by offering a free phone number to the citizens of the United States. And I remember that was in the news, and it was like, wow, why are they doing this? It's such a nice altruistic company. They're doing public good. They're giving people free phone numbers. Oh, they can even do free phone calls. And that was during the time when we still didn't have IP-based phone calling. We didn't have Skype. We didn't have WhatsApp phone calls. So it really felt like a big deal. Now, why were they doing that? Because they wanted to record all the calls, and they wanted to transcribe all the calls, and they wanted to teach their AI algorithms speech recognition. That's why your phone these days recognizes your speech so well. And that's why Google has this tiny microphone icon in their text input, and you can just talk to your computers, because they have crowdsourced the content that is needed for the AI algorithms to understand human language. So they are basically offering a public service to do good, and the entire purpose of that service is to collect data for their algorithms. They do the same with their map service. So you see the traffic data in Google Maps. In big cities, it's pretty accurate. Because of the traffic data, they can suggest you the fastest route. Well, how do they get the traffic data? Everyone who has an Android phone and is using Google Maps is providing that data. They know how fast or slowly the cars move on different roads because people are using Android phones and Google Maps. So there is a beautifully baked in network effect there. The more people are using Google Maps to navigate, the better Google Maps becomes in supporting navigation, which means that as a big crowd of people, you want to be using it because it's so good. And the more you use it, the better it gets. And then a couple of funnier pictures that I found online, basically taking the idea of CAPTCHA to the next level. Especially the one on the right is interesting. Hey Google, exactly what kind of AI am I helping you guys to train with this? And I'm not sure if this is actually a real picture or if this is a fake one, but for the sake of discussion, it doesn't matter because it's really funny. You can see what people are actually training there. It's some kind of a drone technology or warfare technology, AI for warfare, by solving these modern CAPTCHAs of Google, which are actually pretty difficult. Sometimes you have to identify like all the traffic lights in a picture, and it's just impossible to find all of them. And you have 5 of these in a row, and you spend 2 minutes of your precious time, of your limited time on this planet, training Google's AI algorithms in order to access something that is on the other side of that CAPTCHA, and it can be really annoying. Okay, labor quality is one thing. Filtering workers, trying to devise algorithms in order to get better labor quality, that's one thing. And then incentives. Why do we as human beings do the things we do? Again, a couple of bigger divisions of these things. We contribute to other people's work. We do work for other people for a couple of bigger reasons: money, love, glory. These are sort of bigger archetypes of why we work. And the simplest possible dichotomy, again, we always want to find this kind of really simple heuristics to keep in mind before diving into the more nuanced ones, are extrinsic and intrinsic reasons, extrinsic motivation and intrinsic motivation. Simple rule of thumb. Extrinsic motivations are when I give you something. So you work for me because I give you money, or I give you something else. I give you tangible goods, or sometimes it's even virtual goods. So if you work for me, I give you a badge online. Now, intrinsic is then something that you work because of, you basically feel like you get something out of it. You feel you connect to some kind of a purpose, psychological reason to do that. Or gamification techniques. So basically, I want to do something because it's fun. There is no other point to it. It just gives me something to pass the time. Charity is a big one. I want to help an organization or something, a bigger entity. So I do things for charity, or just want to help out a buddy. So again, we are, as social creatures, we form connections with other humans and we want to help them. So these are all intrinsic motivations. Money can be used to solve problems online. We already talked about Amazon Mechanical Turk earlier, and here's another example of that. So identify Arabic dialect in text. 14,000 hits, which is a short acronym for Human Intelligent Task. So in this task, people are shown snippets of text and they have to identify which Arabic dialect is present in that text. And they get 5 cents for one single hit always. So money as an extrinsic reward can be used to solve this kind of parallelizable problems pretty efficiently online. But there's a limit to this. So context-specific labor. You cannot get labor for problems that require content-specific knowledge or even physical presence. So if you think of Amazon's Mechanical Turk, it's a pretty self-selected labor force. If I have, for instance, a task where I really need higher education students in Finland or higher education students in Europe, I'm not going to find them from Mechanical Turk. Mechanical Turk audience is largely based in US and India and of a specific type of demographics. And I'm not going to find higher education students in Finland. There are plenty of other platforms which cater to different types of audiences, but we have a big planet with a lot of different types of demographic groups and audiences, and there is just no platform that can cater to everything single need, which means that we have to be good at building bespoke crowdsourcing platforms to reach these distinct type of audiences. So how do we do that? If we have a task that you cannot basically solve with Amazon's Mechanical Turk, examples of these kind of tasks are complex context-specific work. If I want to, for example, crowdsource the new design for University of Oulu campus in downtown, what I need is I need the authentic people who are currently studying at the University of Oulu so that they understand the cultural aspects of it. And we need to support the workers with a specific rubric or structure in order to accomplish a more complicated design task. Who has, by the way, who recognizes this picture of this game? Wow. Why unfortunately, yes. I think it's great that you recognize it. It means that the youth of today are not completely ruined yet, because it's truly a classic game. I hope you don't recognize because it's been redone into some shitty new version, but because of the old version. So anyway, it's a great game that I think it's a good analog to this kind of crowd, which is not perhaps helpless, but that needs some kind of a design so that they achieve something together. Obviously, in this case, they just want to go somewhere, but it's the same thing. You have a crowd of people and you want to support them with different design elements so that they get complex work done. A really archetypal example in research about this is, for instance, building an article, writing an article. You don't write an article about a complicated topic by just asking 100 people that, hey, you 100 people, would you write me an article about nuclear fission? That's just not going to happen. You can imagine the chaos that's going to happen there. If I now ask this class that, would you write me an article about nuclear fission? What's going to happen? There's going to be an initial silence, and then maybe somebody will at some point take leadership basically and come up with the rubric of how we're going to make it happen. Now we can do the same with online crowds. We can first release a task to just a couple of people that, okay, make an outline for an article. Go to Google, find a related article, and make a similar outline. I will send a task to Mechanical Turk for a couple of other users to edit the outline so that it looks better. Find data for each of the subsections. Sort data, write one section, edit the section, repeat until ready. So we can really start building this kind of workflows that have multiple different steps in order to achieve complex work. And it can get really complicated. So there's this paper about hiring crowd workers exactly from places like Mechanical Turk to do website development or content creation, Android development, really complicated stuff. But the key here is connecting all of the dots that we have been discussing now into a rubric or this kind of a sequential assignment, which has different steps that we assign workers for. So we identify the workers, we filter the workers who are good at, for example, graphic designing. We filter the workers who are good at development. We filter the workers who are good at writing content. And we assign them to different parts of the puzzle. And then the puzzle gives birth to some kind of a bigger entity. Much like the article example, but this is, I'm leaving the link here to the publication if you're interested to see how it works. So you can build this kind of entire organization from the sort of nameless people in Mechanical Turk who are only represented by their IDs. Rank, vote, figure out things together. Another fun example of what the crowds can do when they're orchestrated nicely is this company called Innocentive. So Innocentive is basically a problem-solving company. You give them a big problem or a big creative task. This is used by companies like Coca-Cola, for example. Their problem could be something like, what would be the next big theme in our global advertisement campaigns? Or it could be something much more actual problem oriented, like how do we solve problem X, Y, and Z? 100,000 people pitch in with their own proposals. The same 100,000 people vote and upvote and downvote the other proposals. They improve upon the proposals. And then whatever bubbles up, the solution that bubbles up wins the prize. So it's a prize model. Coca-Cola puts 100,000 there and says that whatever problem wins in the end, the contributors get to share 100,000. So people participate this for two reasons. There's the extrinsic reason, they might win something if they come up with good stuff, but there's also the intrinsic reason of simply wanting to see if they have the brightest ideas. So there's like a game-like competition going on at the same time. So they're pulling a couple of nice little psychological strings here in order to make people to contribute to their real industry problems. Just like I said earlier in the example about the big screens, it's not only online. Most of the crowdsourcing work, probably 99%, happen online, but it's good to acknowledge that this can be also done in much more mundane settings. So this picture you can probably recognize as being from the Linnanmaa campus. What we have been doing in our own work is also something called situated crowdsourcing a lot. So we deploy interactive interfaces around us in our environments. And those interfaces can be used to deploy any kinds of interactive tasks on. So I think this was part of coursework earlier that we did, where we built basically this kind of a market, much similar to what Mechanical Turk is doing, that we can deploy any arbitrary tasks, and students could basically walk up to this device and start completing those tasks. And it doesn't have to be a student, it can be a staff member. When we were doing this, there is a funny story, or it's not even a funny story, it's just a story, it's a fact. We were looking at the data collection, basically just refreshing MySQL database backend and seeing that one of these devices was used for over 5 hours by the same user in a row. So we walked there and asked the guy that, are you sure? Have you been here 5 hours working on these tasks, and what's going on? What's happening here? And we had a main prize in this study where we were giving an Android tablet for the person who first does enough or completes enough units of labor, using the same terminology that we're using on this lecture, who completes sufficient amount of units of labor gets an Android tablet, and the wife of that said worker had ordered him to get the tablet for them. So there he was, 5 hours doing these tasks on one of our kiosks on the campus. What we were doing there, we had tasks like finding Waldo, which is really silly tasks, but just something that we want to see how this kind of situated crowdsourcing market works. You can do something more imaginative, passerby crowdsourcing. You can see where people walk. You can make a polling infrastructure that's just asking people, is this a cat? Yes or no? Again, the same image labeling task that is so common everywhere, but people vote by walking. You choose that lane. You choose the left lane if it's not a cat, you choose the right lane if it is a cat. And you can do this kind of public polling systems where people vote by their physical movements. What else you can do? You can do crowdsourcing in teams. And what we have been doing, for instance, in small teams is seeing again this dodgy example. So whether teams are better at recognizing dodgy items in pictures than single individuals. And okay, these are just examples of things that can be done outside the realm of online. Now, the big thing in crowdsourcing, I bet that some of you have thought about this, but open source is essentially nothing else than crowdsourcing of software. We have an extremely elaborate way of synthesizing the units of work. There is a built-in filtering mechanism. Somebody approves your pull requests or not. They control the quality of the contributions. There is a built-in reputation mechanism. If you go to a GitHub and you see people's profile, you will get an intuitive understanding of how good of a contributor is this person to different projects. Open source is really like the example of success of crowdsourcing. Facebook. Now, what makes Facebook successful? It's not the software. The software is pretty dumb, or it started as pretty dumb. Now there's widgets for everything, of course, but it was just a stream of content. The content wasn't produced by Facebook, which means that essentially Facebook was crowdsourcing the content, and people were producing the content out of intrinsic reasons because they sure as hell weren't being paid for it. So you were producing the content for social reasons. YouTube is doing the same. People are voluntarily contributing the content, and they're just crowdsourcing all of their offerings they have. Now they have some YouTube originals, but who watches those anyway? Uber is crowdsourcing a taxi service. It's making people contribute small units of taxi rides. So the list goes on and on and on. And this is also why I was trying to make the point earlier that this crowdsourcing as a concept is really not something that has been invented by computer scientists, but you can try to open your eyes and see parts of the world that are based on this model of someone synthesizing units of labor produced by others. And now, if this was a 10-hour lecture, I would go into wisdom of the crowd, but there is no way that I'm going to try to jump through this in just 15 minutes because I want to take my time talking this. So what we're going to actually do is we're going to cut it here.